All right, so we are moving on to session 3 for lesson 28, and this is basically just a review of some of the things that we've learned about categorizing, or we're learning about the details of two-dimensional figures. So let's get right into the warm-up. Our warm-up wants us to make a tree diagram, and if you remember, a tree diagram is like a ranking of the most general or simplest down to the most complex or detailed. So we start at the top with simple and work our way down to more specific shapes or more descriptions. I've got triangles, polygons, and acute triangles. So since I know a polygon is a really general description of a shape that has straight sides and is enclosed, I start with that one. Ironically, I'm using a polygon to put the word polygon inside it. That leaves us triangles and acute triangles. Well, I know a triangle is just a three-sided figure. So that's next. And that leaves us an acute triangle. And that's very specific as far as one of the angles has to be acute. And again, you go from very general and then you work your way down to more specific and complex. So just a nice review of a tree diagram. And also when we talk about ranking, we can use that word hierarchy. And that's just a good word to stash away for the future. All right, please open up to page 583. So let's talk about regular polygon. So regular polygon has all sides of equal length and all angles of equal measure. So we got to underline all sides of equal length and all angles of equal measure. And it gives us these shapes below. It gives us squares, pentagons, equilateral triangles, and hexagons. And if we want to talk about one where it's always the case where all sides are equal, that would only leave us with squares and equilateral triangles. You can have pentagons and hexagons have all equal sides. That's possible, but it's also possible to stretch some of those sides so that's still, in this case, a five-sided figure. And this is a six-sided figure. But it can also be a hexagon or pentagon without having equal sides. Squares and equilateral triangles, by definition, have to have that. So they're considered regular polygons, and then pentagons and hexagons are not. But you will see pentagons and hexagons that fit this description have equal sides and equal angles. So a tree diagram, like over here on the left, can use two lines to show subcategories that do not overlap. So tree diagrams are not always straight up and down. In fact, there can be this one like here in this case where scalene triangle is kind of different than the isosceles. Then isosceles and equilateral can be grouped together. So his diagrams are correct. Yes, they are correct. And the reason being is because a scalene triangle, if you don't remember, has three sides. That should be the word three. Let's try it again. Of different lengths. And we know that an isosceles triangle has at least two sides that are equal, and an equilateral has all three sides are equal. So that's why this one is what we kind of call an outlier, like it lies outside of the normal stuff. So he did do these correctly. Good for you, Jose. So this is pretty simple. Describe the attributes of a shape that's both a rectangle and a rhombus. It's really simple. You can just create yourself a square, and this counts as a rectangle and a rhombus. by its definition. So a rectangle has 4 right angles, which this does, and a rhombus has 4 equal sides, and then 2 pairs of parallel sides, which is also a square. So a square can be a rhombus, in fact. So it's interesting that a square can be both a rhombus and a rectangle. All right, so let's look at the next page. Jake makes a tree diagram to show the hierarchy of polygons. So polygons are figures that have straight lines, and all straight lines, and they're enclosed. But explain why Jake's tree diagram is not correct. So let's start from the top. Polygon, have straight sides. His next categories or subcategory is quadrilaterals, which means 4 sides. And then he has pentagons, rectangles, which and parallelograms. Now right here, this is where his tree diagram stops working, because pentagons are 5-sided figures and quadrilateral are 4-sided. So again, you got to be really careful with your tree diagrams and ranking them. Make sure that there's that smooth connection between each step. Part B, does not give me a lot of room here. Draw a tree diagram or Venn diagram to show the hierarchy of the 5 categories in part A. So, in fact, let me use the space up here. We'll start with polygons. Let's call it poly. And this is where we split up into 2 parts. We definitely have our 4-sided figures, our quads, quadrilaterals, and our rectangles, and our parallelograms. But our outlier, one that's different, is going to be our pentagon. So that's why we can connect it because it is a polygon. It just doesn't match up with these others. It's like the one that just isn't like the others. So that works for us. And last question, are rhombuses a subcategory of parallelograms, or are parallelograms a subcategory of rhombuses? Let's use a Venn diagram. Okay, so we've got to think about the general descriptions of these. A parallelogram, it just says a shape that has 2 pairs of parallel sides. And a rhombus is something that has 2 pairs of parallel sides, but all sides are equal. So since I had to add more details to the description of a rhombus, that will go inside here. And my parallelogram will go on the outside because it's more general. All right, let's talk about the homework. It's going to be Z3. You're going to be given an example, and you have to say if it's a regular polygon or an irregular polygon. And remember to review, regular polygons have equal sides. They all measure the same side, and all their angles are the same. So if there's anything different, it's counted as irregular.